Okay, so 6-3 Proving Parallelograms is an extremely short notes. That's because the majority of our information from this section comes from 6-2, okay? So all we're really doing is just using the facts that we learned in 6-2, but backwards, okay? And what I mean by that is instead of saying if something's a parallelogram, then these 5 facts are true, we're going to say if any one of these 5 facts are true, then it's a parallelogram, okay? That's all we're really doing. One thing that I do want to mention is that you need to double check both pairs of things. And it's not just on opposite angles congruent, but we're tempted right here to be like, hey, opposite angles are congruent. These are both 75. And say, wow, that means that it's a parallelogram. Unfortunately, this is not, because right here we can see these consecutive angles don't equal 180. So that's why we got to be careful. If we actually did this, we could add up. This is 75 plus 75 is 150, plus 100 is 250. Quadrilaterals equal 360. 360 minus 250 is 110. So very clearly, this angle right here, 110, does not equal this 100 angle. So you need both pairs to say that it's a parallelogram, okay? There's quite a few reasons on here. Use these when you're doing Math Excel or textbook problems. You need to write these out, okay? If you don't have your reasons, if you're not showing your work, I can't give you full credit, okay? For any of the problems in the textbook that say proof, like this right here, you just write your reasons. Your reasons are your answers in that situation. So let's look at some example problems. So this first one, it gives us, let it focus, it gives us that opposite sides are congruent right here. So I can say, yes, this is a parallelogram, and it breaks it down in a lot of steps. Math Excel will do the same thing. But in all, we can just say, well, because opposite sides are congruent, I know that this is a parallelogram. It's both pairs of opposite sides, okay? For this one, same thing. We have both pairs of opposite angles congruent. So because of that, and proving it with a lot of other different things, I can say that this is a parallelogram because opposite angles are congruent. So all of those parts play a part in this. Same thing with this next one. Like I said, these are all just a lot of proving. And so I have diagonals on here, and it says that they bisect each other. So we can just use the simple fact that on a parallelogram, diagonals bisect each other. And that can prove to us that this is a parallelogram. These are just different ways the proof will look. You'll see this on Math Excel. But if you're doing textbook problems, you don't need the full length proof. You just need the explanation. Okay. The last 2 types of problems, these are very important because it's actually solving for variables, okay? So we got to use, for this to be a parallelogram, we know opposite sides must be congruent, okay? So I know this side should equal this side. Now, I want you guys to work smarter, not harder. Both of these opposite sides have x's. You can kind of see it. The light is reflecting. Both of these ones have x's. 3x minus 5, 2x plus 1. So I can set those equal to each other, solve for x, then I can plug x in for this one to solve for y. So that's working smarter, not harder. You don't really have to do a systems of equations like we had to do in 6-2 or 6-3. And the last problem, you can solve these one of 2 ways. Right here, it looks like the ones with the common letter, so W's are opposite and Z's are opposite. So I could set these, remember, opposite angles are congruent. So I can set 3W plus 10 equal to 5W minus 30. I can set 7Z plus 5 equal to 8Z minus 10. Now, what if it gave me B and C, both with X's? Well, since those are consecutive angles, I wouldn't set them equal to each other like I did with these opposite angles. I would set it equal to 180. I'd say this angle plus this angle equals 180. And that would even work here, but we don't want to mix variables. That just makes our lives harder. So that helps you to figure out whether something is a parallelogram or not, and it gives you examples. Like I said, all of these examples are on Math Excel, or not Math Excel, on Realize. If you look through them, you can get a more detailed explanation of why and why not these are parallelograms, okay? These both are. And same thing here. We can prove that these are parallelograms as well. It's just that over and over again, and a lot of the problems on here. So we do include 1 through 10, so that's all these ones in here. So knowing, setting these equal to each other. Remember, diagonals bisect each other, so y minus 1 equals 2y minus 7. Opposite sides are congruent. All of those different things. This is alternate interior angles, so those would be congruent. And then it's just figuring out whether this is enough information to prove these congruent. So using that, if you have any questions, text me on Remind. But that's what 6-3 parallelogram, prove it parallelograms is all about.